Happy Wednesday, everybody. Today's shout-outs go to first Ashley for winning Kahoot and coming to Zoom for the first time. We loved having you. And for Camille for coming to Zoom through FaceTime. We loved having the two of you. So definitely come again. Our goal today is to identify functions, which is our last special type of equation. We have three special types of equations that we've talked about. Linear, which means they make a line. Proportional, which means they make a line and also go through the origin. And today we're going to talk about what functions are and what makes them special. So we've worked with these equations all year long. We're just recognizing when some of them are more special than others and have other names. So let's get started. So functions, you've actually have worked with functions all year long. Most of the work we've done has been with functions. In grade school, you did input-output machines or function machines. The input in math is called the x. The output is called the y. And we'll talk about some other ways of writing it. Instead of writing y, you could also write f of x, which is a fancy way of writing the y. Or you could just say output. So if the teacher told you she put a 3 in the machine and it spit out a 5, and then she put a 4 in the machine and it spit out a 6, you tried to figure out what happened inside the machine to change the number. In this case, it would be +2. But let's say you put a 3 in, you got a 5 out. You put a 4 in, you got a 6 out. Then later on, you went back to the machine and you put a 3 in, and you got a 14 out. That doesn't make any sense. You can't put a 3 in and have it become a 5, and then put a 3 in and have it become a 14. If you put a 3 in, you have to always get the same thing out. Because this 3 repeats and gives you different things, the machine is kind of like a broken machine. So in math, we say that that's not a function. To be a function, you can't put the same thing in and get something different out. That does not work. So functions, like all equations, except for equations that put the same thing in and give you different things out. So we want to be able to spot these. And so we're going to talk about the table first because that's the easiest way to spot whether or not you have a function. So for it to be a function, we can't have any x's repeat. So we're going to just look at the x's. We don't care about the y's. We're only going to look at our x's. And we're looking to see if x's repeat. In this case, the 3 repeats. Sometimes the 3 became a 4, sometimes the 3 became a 6. That means this is a broken machine, so it's not a function. Over here, if we look at our x's, none of them repeat. So this is a function. So yes, this is a function. You don't need to figure out what happened inside the machine. You just have to know that yes, this is a function. And some machines change what they do, but here you don't have any x's repeating. That's all you're looking to see. Now from a set of points, this is also very easy. We're going to look at our x's and make sure the x's don't repeat and give you something different. So in the first row of ordered pairs, I noticed that the 2 became a 6 and then the 2 became a 7. You can't have that and be a function. The x's can't repeat and give you different things. We don't care about the y's, we only care about the x's. In B, going across here, I have a -2, a -7, a 4, a 3, and a 4. So the 4's repeated and became different things. So this is not a function. For C, I have a -2, a 5, a 2, a 3, and a 4. None of my x's repeat, so this is a function. This does work. And then for the last one, I have a -9, a 5, a 2, a 5. 5 became 9, 5 became -9. That does not work. That's not a function. Now for our next category, you want to be able to pick out a function from an equation. So all of the equations that we've done this year have been functions except for VUX. If you think about a VUX is a vertical line, which means the x number is always repeating. You can't have the same x number over and over and over again. So x, if there's only an x in the equation, it's going to be x'd out. That can't be a function. All the other equations that you've graphed this year are the linear equations, all the equations without powers are functions. So our y equals our Hoy's are, and our y equals mx plus b's are. If you have an equation that has powers with the variables, you want to look at the y. The y cannot be even. If the y is even, then we're going to x it out. We're not going to deal with these this year. We're just going to be focusing on the linear, and you'll only focus on the linear ones at the beginning of next year as well. Eventually, when you get to Algebra 2, you'll start looking at ones like this. So for now, the equations that you know of, the VUX is the one that does not work as a function. So functions are kind of snobby. They don't like VUXes. Now, from a graph, we're going to do what's called a vertical line test. So if you don't want to have any x's repeat in a graph, if the VUX equation is a vertical line, and that means the x's keep repeating over and over, for something to be a function, it has to pass a vertical line test, which means on the graph, you need to be able to draw vertical lines throughout the whole graph and never hit more than one point on the graph. So this is the graph, that little curve. If we draw lines up and down, we'd never hit more than one point. So yes, this is a function. If I come to my next graph, if I draw a line up and down here, I hit this point and I hit this point. This is not a function because that means that the x numbers repeated and gave different y's. So when x was 2, it was here and it was also here. That does not work. For the next graph, if I just draw vertical lines, I'm going to hit more than one point throughout the graph. So this is also not a function. In my last one, if I draw vertical lines up and down, I hit more than one point on the graph each time I do that. Here I hit this vertical line, hit this point and this point. So this is not a function. So it has to pass the vertical line test to be a function for a graph. Now for our next category, this is a new category. It's called the mapping diagram. A mapping diagram is something we draw for ordered pairs, and it's just a picture of the ordered pairs, and we put the x's in the first oval, and we put the y's in the second oval. And then instead of writing out the ordered pairs, we draw lines connecting things. So this mapping diagram, these are all the x numbers written in numerical order, -1, 1, 2, and 4. And it tells you what it matches up with. So -1 matched up with 4 as one ordered pair, but -1 also matched up with a 3 as another ordered pair. 1 matched up with 1, and 1 matched up with 2. So we're just making a picture instead of listing ordered pairs. We can tell that -1 became two different things, which is not allowed in a function. If we go to the next mapping diagram, -1 became 6, 0 became 1, 1 became 0, 2 became 2, 3 became -4, and 4 became 1. None of these x's went to more than one thing over here. So this is a function. Now we want you to be able to also make a mapping diagram. So to make a mapping diagram, you take all of your x numbers. So we have a 2, a 5, a 2, a 4, and a 5. We're going to put them in numerical order and we're not going to repeat them. So I'm going to write the 2, the 4, and then the 5. Those are the 3 different X numbers that we have. Over here, I'm going to use my second oval for my Y numbers. We have a 6, a 9, a 7, a 9, and an 18. Again, I'm going to put them in numerical order, so I'm going to write 6, 7, 9, 18. Now to draw my lines, I'm going to look at each ordered pair and connect those 2 numbers. So 2 matches up with 6. 5 matches up with 9. 2 matches up with 7. 4 matches up with 9. And 5 matches up with 18. So this is a mapping diagram of these points. It's not a function because the 2 repeated and the 5 repeated, and you can tell because it was connected to more than one number. So this is not a function. And now the last part is we just want you to start recognizing vocab that we use when we talk about functions, and we've used these words already with you. Domain is a word that you'll hear a lot in math. Domain is just another word for X. So if you hear someone say domain, just think of the X numbers. It's also the same as input or independent variable. They all mean the same thing. Range has 2 meanings in math, which is what makes it kind of confusing because you've done range by subtracting your largest and your smallest number, but range also is another word for Y, or output, or dependent variable, or this fancy f of x notation that you'll see, and you'll see that more next year. Then these last 2 words, sometimes you see a graph and it's just a collection of dots, and some of you like to try and connect the dots, but sometimes a graph shouldn't be connected because not everything works. So if you were graphing number of cars sold versus profit, you technically shouldn't connect these because you can't sell 1.5 cars. You can only sell actual numbers of cars. You can't sell all the fractions in between. So this would be a situation where technically you shouldn't connect it. In math, we kind of start just connecting them because people like to see the dots connected. But sometimes when you see them not connected, it's because the person is saying not everything works. So if it's continuous, that means you connect the dots because that means everything works. If it's discrete, you don't connect them because only certain numbers work. So this would be an example of discrete data. Continuous might be your age and your weight, your age and your height, where you can have fractions of both of those numbers. So it would make sense to connect all the points because you're showing what happens in between. So now you're going to do some practice with this, answer a few questions on the form. Always, you can check out Flipgrid. Have a nice day.